In this edition of Real Life Orgo, Group 32 will be talking about the use of anabolic steroids in athletes. So before we get into the use of anabolic steroids in athletes, we should probably talk a little bit about the structural basis of steroids in general. So steroids can serve a variety of different purposes in the human body, so overall they're too large of a topic, but steroids in general are composed of 4 fused rings that are 3 cyclohexane rings, as well as 1 cyclopentane ring. The cyclohexane rings are labeled 1, 2, and 3, and the cyclopentane ring is labeled 4. The most common substitutions on these rings tend to be on carbon 10 and carbon 13, as circled here, and particularly on the outer rings, which are labeled with arrows. And that's going to be due to steric hindrance. It's really hard to get substitutions on the middle rings because if something wants to attack or do a substitution reaction, it's difficult to get in around the hydrogens hanging off of these other rings, and sometimes the functional groups as well. And it's worth noting that you can see, because of all these ring structures here, that a lot of these steroids can be aromatized within the body, and that's a really good thing, just going back to what we learned earlier this year about how aromatization provides a lot of stability to molecules through that resonance energy of the conjugated bonds. Now we can move on to an overview of testosterone. So testosterone is the basic anabolic steroid, and it's found naturally in the human body, both in men and women. It's defined as a steroid hormone that stimulates development of male secondary sexual characteristics, but in women it serves other purposes such as helping to build muscle and other things like that. Just a basic view of how testosterone works in the body. In terms of its cellular function, it will bind to a receptor in the cytoplasm of the cell, which is the jelly in the middle of the cell. It will form a complex there. That complex will enter the nucleus, attach to the DNA, and then it'll activate specific genes for a variety of purposes, but generally for muscle growth and development of the male secondary sexual characteristics in men. Some notable structural components that we have here are going to be the carbonyl group that you can see at the bottom here, and that is in conjugation with this double bond, which provides some stability through resonance energy, and we looked at that in a problem set earlier this year. And there's also a hydroxy group up at the top on the cyclopentane ring, and that you can see is given with stereochemistry as well. And the stereochemistry in this molecule can be particularly important, especially as it undergoes several reactions. Now that we've got a good idea about steroids in general, as well as testosterone specifically, the primary anabolic steroid found in the human body, we're going to talk about a commonly used steroid among athletes, which is methandriol, or 17-alpha methylandrost 5-enediol, and specifically in this slide, how to synthesize it. So the synthesis is actually a Grignard reaction, and all you need is DHEA, which is a legal dietary supplement, which is commonly available. It's distributed throughout this country as well as around the world. You take it, react with an excess of methylmagnesium bromide, and finally treat it with acid, and you are left with methandriol. So we're going to go through the reaction real quick. So we're going to focus just on this cyclopentane ring right here, because that is the one involved in the reaction. So the first step was to treat it with methylmagnesium bromide, which is shown right here above the arrow. And it's a simple reaction with a ketone, nucleophilic addition, so that'll go ahead and attack the carbon. The electrons will come up. And like I said, we're sticking with this cyclopentane ring. I'll draw the final product at the end. So then you're left with a tetracoordinate intermediate here with the O-. Then you would treat this with acid, giving this oxygen, those free electrons, a chance to abstract a proton like so, and leave this cyclopentane ring with a hydroxy group as well as a methyl group, giving you a final product which looks something like what I'm drawing over here at the bottom. And I'm not writing stereochemistry on those because when you change from a planar geometry of the carbonyl to the methyl group as well as the hydroxy group, you're going to get a racemic mix.
Looking at the structures of steroids, you can see that they are very similar to testosterone, but there are some differences. Let's first look at Winstrol and compare its structure to testosterone. Winstrol was brought to market in 1962, the same year as the Kefauver-Harris Amendment, which requires drug manufacturers to provide proof of safety of their products. Now, structurally, both molecules contain the 4 fused rings, but they contain differences in their substituents. For example, Winstrol contains a pyrazole group in place of the keto group on testosterone. On carbon 17, there is an additional methyl group, as well as an inversion of the hydroxy group when compared to testosterone. The next structure we will look at is trenbolone acetate. This drug, under the name Trenibol, was not intended for human consumption, but is used to increase muscle mass in cattle. This provides an insight into how far athletes will go to gain an advantage. Looking at the structure, Trenibol contains a pair of conjugated double bonds on one of its 6-membered rings. In place of the hydroxy group on testosterone, Trenibol contains an acetate group, but there is a missing methyl group when compared to the structure of testosterone. Testosterone cypionate is used in replacement therapy for males with conditions affecting their testosterone levels. There's really not much to say about the structural differences other than the addition of this ester here. This simple change makes little to no difference in functionality of the molecule, making it a really interesting change to observe. In contrast, from the subtle differences between testosterone and testosterone cypionate, let's look at the structure of cardarine. Although this is not similar to testosterone in any way, it can still be used the same way as a doping agent. Cardarine was originally intended to treat cardiovascular diseases, but further production of this drug was put to end in 2007 after showing the potential to produce cancerous cells in the body.
So, why do steroids? The most common reason for abuse of anabolic steroids is to gain more muscle mass. Athletes are very common abusers because the steroids help them play better and stronger. However, steroids have another use. They can also be used to recover from an injury faster due to its ability to catalyze muscle growth. Steroids have many unwanted negative effects on the body. While abusing this drug, the user is likely to experience more body hair, a lower voice, which is more noticeable if the user is a woman, a serious increase in acne, which can be located anywhere on the body, a lower sperm count for men, uncommon mood swings, and if the user is a male, there is an obvious development of breast tissue. The user also suffers from insomnia, and if the method of taking this anabolic steroid is through injection, the person is prone to infection and/or blood-borne diseases, such as HIV. Finally, the long-term effects of consistent abuse of anabolic steroids can lead to heart problems, such as stroke. Also, the user may suffer from paranoia and mood swings, which is where the term roid rage originated from. Additionally, the person is more likely to suffer from kidney failure and damage to the liver, and long-term issues with fertility. The negative effects of this drug really seem to outweigh the simple positive of increased muscle growth. Steroids are a dangerous drug to one's body and should not be taken lightly.
So now let's look at some of the athletes who have admitted to using steroids. First we'll look at Alex Rodriguez, who admitted to taking them between 2001 and 2003. In the chart, you can see that his batting statistics took quite a large jump during that time period. He averaged about 15 more home runs per year than in previous years, and his slugging percentage and runs batted in increased quite a bit as well. He would later be suspended by the MLB for a total of 211 games after he admitted to taking steroids during this time period. Mark McGwire is known as one of the most powerful hitters of all time. He admitted to using steroids during the 1998 season and occasionally throughout the 90s. Mark holds several MLB records, such as the fewest at-bats per home run, where he averaged a home run every 10.6 times that he visited the plate. He has the most home runs in a 4-season stretch, recording 245 during the time, and he's also second to only Barry Bonds in most home runs in a single season. He also hit the second longest home run ever, recorded at 538 feet back in 1996. So now let's take a look at how athletes are getting caught using performance-enhancing drugs. Professional sport organizations have drug testing policies that the athletes must abide by. In the MLB, for example, each player has 2 random drug tests throughout the year, as well as 1 drug test that will be tested by carbon mass spectrometry. If a player ever tests positive, he will then have an additional 6 urine tests and 3 blood tests until he retires to prevent the use of steroids. Let's take a closer look at the actual testing now. The body naturally produces a ratio of testosterone to epitestosterone at about a ratio of 1 to 1. When you use steroids, the amount of testosterone will actually increase, and a failed drug test is when the ratio of testosterone to epitestosterone exceeds 4 to 1. After a failed first test, a second confirmation test is used using carbon mass spectrometry. Testosterone is naturally produced by the body with a ratio of carbon-13 to carbon-12 that is smaller than what naturally occurs on Earth. So when an athlete takes steroids, the amount of carbon-13 in the testosterone actually increases. Mass spectrometry is then used to see the amount of carbon-13 that will appear in the sample. If the ratio of the carbon in testosterone deviates from the natural testosterone levels by more than 3 carbon-13 atoms per 1,000, it is a failed drug test, indicating that the athlete used steroids.